IP addressing. IP stands for Internet Protocol. One of the most important topic in any discussion of TCP/IP is IP addressing. An IP address is a numeric identifier assigned to each machine on an IP network. It designates the specific location of a device on the network. An IP address is a software address, not a hardware address. A hardware address is hard-coded on the network interface card or the NIC card and is used for finding hosts on a local network. IP addressing was designated to allow hosts on one network to communicate with a host on different network, regardless of the type of LANs the hosts are participating in. I am going to explain some of the fundamentals of IP addressing and its terminology. IP terminology. You are being introduced to several important terms that are vital to understand the Internet Protocol. Bit. A bit is a one digit, either a 1 or a 0. Byte. A byte is a 7 or 8 bit depending on whether parity is used. For the rest of this chapter, always assume a byte is 8 bit. Octet. An octet is made up of 8 bits. It is just an ordinary 8-bit binary number. In this chapter, the term byte and octet are completely interchangeable. Network address. This is the designation used in routing to send packet to a remote network. For example, 10.0.0.0, 172.16.0.0, 192.168.0.0. Broadcast address. The address used by application and host to send information to all nodes on a network is called broadcast address. For layer 3, broadcast is 255.255.255.255. Let me take you to another example. For the network 172.16.0.0, the broadcast is typically 172.16.255.255. And for the network 10.0.0.0, the network broadcast is typically 10.255.255.255. Hierarchical IP addressing schema. An IP address consists of 32 bits of information. These bits are divided into 4 sections referred to as octets or bytes, with each containing 1 byte, 8 bit. You can depict an IP address using one of the 3 methods. Dotted decimal 172.16.30.56, binary as shown in the figure, and hexadecimal as AC.10.1E.38. All these examples represent the same IP address. Pertaining to IP addressing, hexadecimal isn't used as often as dotted decimal or binary, but you can still find in some softwares. The 32-bit IP address is a structured or hierarchical address as opposed to a flat or non-hierarchical address. Hierarchical address was chosen for a good reason. The advantage of this scheme is that it can handle a large number of addresses, namely 4.3 billions. 2 possible ways at each position, that is 0 or 1, gives you 2 raised to 32, approximately 4.3 billion hosts. These 2 or 3 level schemes can also be compared to a telephone number. The first section, the area code designated as a large area. The second section, this prefix narrows the scope to a local calling area. And the final segment, the customer number, zooms in on the specific connection. IP addresses uses the same type of layered structure. Rather than all 32-bit being treated as a unique identifier, as in flat addressing, a part of address is designated as network address and the other part is designated either the subnet and host or just the node address. You need to have a knowledge of binary to decimal and decimal to binary, and I will be creating a video on this topic. The network address, which can also be called a network address number, uniquely identifies each network. Every machine on the same network shares that network address as a part of its IP address. For example, in the IP address 172.16.30.56, 172.16 is the network address. The node address is assigned to and uniquely identifies each machine on a network. This part of the address must be unique because it identifies a particular machine, an individual as opposed to a network, which is a group. This number can be referred to as a host address. In the sample IP address 172.16.30.56, the 30.56 specifies the node address. The designer of the Internet decided to create the class of network based on a network size. For the small number of network possessing a very large number of nodes, they create the rank class A network. At the other extreme is the class C network, which is reserved for a numerous network with small number of nodes. The class distinction for network between a very large and a very small is predictably called the class B network. That is, class B is between class A and class C. To ensure the efficient routing, network designer defined a mandate for the leading bits session of the address for each different network class. For example, since a router knows that a class A network always starts with 0, the router might be able to speed up a packet on its way after reading only the first bit of its address. This will be discussed later on in this chapter. Like and subscribe this channel. If you dislike, please leave in the comment section below. Thank you for watching.